Hello, let's go through midterm 2 from spring of 2021. We have two spreadsheets containing information on individual investments from TIA Real Estate Fund, one spreadsheet from December 2019, the other one from December 2020. And we have all kinds of information about each property. Let's connect the data to Tableau using a union. How many observations we have, what is the unit of observation. So let's do that. Let's connect to data. The spreadsheets are CSV files, so we're going to use text file, connect to a text file. Let's start with property values 2020. I'm going to connect those values there. We can see those different fields, and we're going to convert this to a union, and we're going to add the property from 2019. So let's find it. There it is. That's our union. We're going to say OK. Now we have this new table name field that tells us which table each observation comes from. Property, that's a text, location, text, square footage, number, percent leased, number, fair value, number, category, text. Okay, so that looks all very good. How many observations do we have in this union? 338. What is the unit of observation? So let's see if property is the unit of observation. Not quite, because it looks like a lot of properties have two observations, partly because we have those properties in both 2019 and 2020 data. So probably table name is going to give us the unit of observation because it tells us that, for example, this property, we see it in the 2019 and 2020 data. So the unit of observation really here is property and year. And we might as well actually create this field called year, because I think that's going to be very handy later on. So let's create calculated field. Now let's see what that table name field looks like. So it's got underscores and it's got 2019.csv. So let's call this field year. And let's use the split function. We're going to split table name on underscore, and we'll take the fourth item. So when we slice it by underscore, we get 1, 2, 3, 4. So the fourth piece is going to contain everything that comes after the last underscore. So it will be 2019.csv or 2020.csv. And we don't want the CSV there either. And so we're going to do one more split on whatever the result of this is. Split that 2019.csv, and we're going to split that on a dot and take the first item. Let's see, calculation is valid, so we're going to say OK. Let's see if that works. Yeah, excellent. We've got a year. So we can now even say there, the unit of observation is property, property name, property address, it looks like in most cases, and year. That's the level of granularity of the data. Excellent. What else do we need to do? For the three categories for which we have square footage information, so it looks like we have square footage only for office, retail and industrial, but not for residential properties. So for those three categories, office, industrial, and retail, create a bar chart showing the average value per square foot across individual properties by category and year. So we should have 6 bars, 3 categories for each of the 2 years. All right, fantastic. So let's do that. So it looks like we need to create a new field because we don't have property value per square feet. We have property value and we have square footage, but not value per square foot. So let's do that. Let's create a calculated field, value per square foot. And let's make that fair value divided by rentable square feet. Okay. So we'll say okay to that. Let's see what that looks like. 88,000 is the sum. Of course, we don't want that. We want average. But actually, let's first set up the table. We want to have it by category, and we want to have it by year, and we want to make it a bar chart. Let's make it a vertical bar chart. And so value per square foot, we're going to put on rows. Let's actually exclude residential properties. We don't have information on square footage, so we can calculate value per square feet. Let's make it a little colorful, put the category on color, and excellent. We can see very nicely what's going on here. Office properties. Oh, actually, let's turn it into average. We have to turn it into average because we want to know across the properties in each year, what is the value per square foot. And so office properties are definitely by far most valuable per square foot. You know, those are office buildings in downtown areas. Those are expensive per square foot. Industrial, by far the cheapest ones. Industrial properties, you know, if you have a warehouse per square foot, that's definitely not as expensive as an office building or retail building. Also, interestingly, we see that between 2019 and 2020, office property values dropped quite a bit. When everyone's working from home and everyone is ordering stuff off the internet, office properties and retail properties are not that valuable. Whereas industrial properties, you know, warehouses where you can, from which you can ship goods, those maintained their values. So that's question 2. In question 3, we're supposed to do the same thing, but pay attention to whether we use an average across properties or using aggregate value in each category per square footage in that category, right? And it's really useful when we have some properties that could be small, but have really skyrocketed value per square foot. And if you look closely, there are actually some properties in downtown DC or downtown New York City that are relatively small and pretty expensive on a per square basis. So let's create a new measure of value per square foot. Let's call that aggregate value per square foot, and it's going to be sum of fair value divided by sum of rentable square feet. Excellent. It has errors because we didn't close the parentheses here. Fantastic. We'll say okay to that. Let's actually duplicate this sheet. So all we have to do is replace the measure of average value per square foot with the aggregate measure of value per square foot. And we see that the conclusions remain the same. In the drop in the value of office properties is a little lower, but we still see office properties by far the highest value per square foot and experiencing decline, just like retail properties and industrial properties having an increase in value per square foot. So the magnitudes are very different. Here we had average value of office properties at $650 per square foot. If we use the aggregate measure, it drops down to about $450 per square foot, clearly indicating that there were some really pricey properties that didn't have much weight in the overall category. So they had small square footage, but really high prices per square foot. And that's what drives the difference between the average price of properties per square foot versus the aggregate value of, say, office properties per square foot. Okay, so in question 3, we're supposed to, no, question 4, create a horizontal bar chart showing the number of distinct properties that the fund invested in over the 2-year period by category. So let's do a new sheet. We want a horizontal, so we're going to put categories on rows, and we want the number of properties. Now, property is a measure, sorry, it's a dimension, but we want to count the number of distinct properties. So let's create a new measure, create a calculated field. Let's call it number of properties, which is just count distinct of the property field. Gonna say okay to that, and then let's put it on columns, and let's put again category on color, so it's a little colorful, and we could see the number of industrial properties, the number of office, residential, and so on. So this is the number of unique, distinct properties that they have. Fantastic. In question 5, create a field that contains the city where the property is located and another field that contains the state. So how do we do that? So we have this field called location. Let's see what that looks like. Let's put it on the rows shelf. And it looks like there's a city, comma, and state. So mostly, right, Denver, Dallas, you know, some of them will probably not be recognized. Dallas and no space, couple, that's probably not going to work. I think there's a various.usa, so that won't work. But more or less, San Diego, San Francisco, it's a city, comma, state. So we have to create, let's start with city. We're going to split our location field on comma, and take the first guy because we're going to take the city, whatever comes before the first comma. We're going to say okay to that. Let's now duplicate it so we don't have to retype everything and edit it. We're going to create, we're going to call this field state. And we're going to split again location, but this time let's split location on comma and space, and take the second part after the split. So it's going to take whatever comes after the comma and space, which in most cases is going to be the 2-digit abbreviation for state. We'll say okay to that. We've got city, we've got state. There it is. That looks pretty good. It works. We can actually take location out. How many locations total? It looks like 110 different locations. All right, fantastic. So in question 5, question 6, we're supposed to create a symbol map showing the location of properties. And the color of each symbol should correspond to the category of the property. Size should be proportional to the combined value over the 2 years, and so on. Okay, well, so let's do this one. Let me open up a new sheet. In order for us to be able to create a symbol map, we need the city and state to have geographic role. So let's assign these field geographic role. City is basically a city, and what we call state should be a state / province. Fantastic. So we can double click on city. Tableau uses its built-in knowledge of location, longitude and latitude for each city. Now, of course, some cities exist in multiple states, so we want to add state to detail so that we can help Tableau identify where the city is, if it's Albany in New York State or Albany in, I think there's one in Alabama actually, but I'm not so sure. So it's 102 marks. Now we want to make size proportional to the value. So let's do that. And we want color to correspond to the category. Now let's make the size a little bigger so we can see what's going on. Maybe even a little bigger. Let's try to avoid some overplotting by making these circles a little transparent. And fantastic, clearly you see lots of office properties along the coast, East Coast here in New York, Washington, Boston, and in California. There are some industrial properties here in Washington. Oh, wow, lots of big residential properties in Orlando. How many marks do we have? We have 127 marks, which means that we have 127 combinations of state, city, and category. Right? This is a lot smaller than the number of observations because a lot of the observations are properties that we observe over multiple years. In addition, if specific location, if the same location, the same category has multiple properties, it would still be just 1 mark. So 127, that looks like it's in the right ballpark. Fantastic. And next question, we're supposed to create a dashboard where we have the map and the bar chart from question, I think it was question 4, showing us how many properties we have. So let's put that one on top. Let's resize that. We probably don't need this legend. Let's make this legend floating. Fantastic. We can maybe we can actually put the legend right here. We could even get rid of the category title to make it a little smaller so that it fits into this piece of Atlantic Ocean. Let's hide this title. Let's hide this title. Let's make it still a little smaller. Let's add a title to the whole dashboard. What should we call this? This should be location and value of of properties by, how about this? No, value by category. All right, and we could maybe center it. All right, so that's a decent dashboard. We have a number of properties and here where they are located. The other thing we need to do is we're asked to create an action to make it a little interactive. It should be a filter action where we're going to use the sheet 1 as the source of the action and sheet 6, which is our map, as the target of the action. Action should run on a hover, and it's filtering so that when we hover over the bar, that shows the number of industrial properties we see, where the industrial properties are, and similarly for office buildings, residential, retail, and so on. Okay, so that's our dashboard. That's question 7. Fantastic. In question 8, we're supposed to also create a map, but in this map, each state's color is supposed to tell us what's the top category of investments in that state. So let's first figure out what is the top category investment in each state. So let's put state on rows. Let's put category on columns. Let's put fair value into the table. Let's create a table calculation that's going to tell us which category is a number one in each state. So we're going to do rank. We're going to make it unique just in case there's a tie, and we're going to do this across so that for each state we have we know what is number one, what's number two, and so on. So I'm going to say okay to that. Perfect. In Alabama, retail is number one. In Arizona, it's office. Same in California, residential in Colorado. I've been in Florida. It's residential as well. Where's Florida? There. No, actually, it's retail. Perfect. Now we know which category is top one in each state. Now to identify those combinations, let's filter the rank so that we only see the category and state combinations that are number one. And we can create a set of these combinations. Let's call that create a set. We're going to call that top categories by state. Fantastic. All right. So let's go to our next sheet and let's plot the states. I'm double clicking on the states. We're supposed to make it a filled map. There we go. We're supposed to put category on color. But of course, right now we're plotting all the categories on top of each other because some states have multiple categories in them. We only want the categories and states, only observations that have categories and states that are number one. And that's what this is. That's why we put that set, and we only include categories or observations that belong in that state. So we see that industrial properties are top in Washington State, and it looks like New Jersey. Here, Minnesota, it's residential properties, and retail in Florida, and so on. Let's put a label on these. So we have this category that has the word properties at the end. Let's get rid of that second word, properties. Let's only keep the first part. So we could, again, replace properties with nothing. How about we use that method? I'm going to call this category. How about call it one word. And we can just replace, and from category, we wanted to take properties, and replacement is nothing. We could have also done this using a splitting on space. We could have created aliases, but I think this will work just fine. Okay, and let's put that one word category on label, and that looks pretty nice. Looks pretty nice. We should probably also change that on the legend so that the legend only says industrial, office, residential, and retail. Fantastic. So that's our question 8. Question 9, what are we supposed to do in question 9? So we're supposed to use an LOD expression to create a bar chart showing the total value of properties in each category averaged over the 2 years. So 4 bars, one for each category. The height of each bar is the average of the 2019 and 2020 values. So what does this really mean? So we want 4 bars. So let's do, again, a category, and we want some measure of fair value. So we know, so if I do something like this, I know that over the 2 years, the combined value over 2019 and 2020 is about almost 8 billion for industrial, almost 18 billion for office, and so on. If I change this to average, what am I going to get? I'm not getting the average value of all the office of the office category in the average value in 2019 and 2020. Instead, I'm averaging across all the properties in all the years. Right? So the average value of individual properties across all those 2 years is about 190 million per property, right? I want to have average value averaged over 2 years by category. So how could I do this? Well, one thing I could do just to sort of see what the ballpark number should be is if I put category here, and I put year over here, and I put fair value, I can see that, let's say for office properties, the combined value in 2019 was 8.5 billion, and about the same, 8.5 billion in 2020. And I want average of these two numbers. Okay, so I want an average of 8.58 and 8.56. So how do I do that? How can I do that? Well, I need to create an LOD expression that is value of a category by year. And so I'm going to fix the level of aggregation at the year and category level, and within that, those combinations of year and category, I want to add up the fair value. All right, so I'll say okay to that. Let's say if I put this in the table, I'm going to get the same values, right? Because this is just adding up values across properties within each category in each year. Now, if I get rid of a year, it's still the same because I have the sum of fair value, and now I have a sum of that value by category and each year. But I can change the method of aggregation on that LOD expression from sum to average. Now I get that the number at the top, that's the combined value over the 2 years, whereas the number below is the average of our LOD expression. So it's the average of those two numbers. It's the value of the total value of all the industrial properties in 2019 and 2020, average over those 2 years. So that's exactly, those numbers are in the right ballpark, and that's the number that I want to plot here. So let me replace that in my bar chart. So I have a value of category by year. Replace that, change the method of aggregation to average. So I'm essentially averaging over 2 years the sum of value of properties within each year and each category. Okay, and there it is, about 8.5 for office categories, right? That was the average value that this fund had invested over those 2 years in office properties. Over those 2 years, the average value that they had invested in industrial properties was about 3.7 billion and so on. All right, so that is it. That